So when you take the coefficient of x raised to n on both sides, so that must be equal to 0 on the right side. So when you take the coefficient of x raised to n, we will get n plus 2 into n plus 1 an plus 2 minus n plus n into n minus 1 an, then minus 2n an plus p into p plus 1 an will be equal to 0. So this will give us a recurrence relation which is involving an and an plus 2. So we will get an plus 2 equal to n into n minus 1 plus 2n minus p into p plus 1 by n plus 2 into n plus 1. So that will be, so upon simplifying, or you can rewrite in the form minus p minus n by p minus n into p plus n plus 1 by n plus 1 into n plus 2. So an. So this numerator can be rewritten in this form. So you will get minus of p minus n into p plus n plus 1 an by n plus 1 into n plus 2. So we have got the value of an plus 2. So an plus 2 is minus of p minus n p plus n plus 1 by n plus 1 into n plus 2 an. So now we can so n starts from okay, so here you need to take from 2 3 so on. Column a2 can be expressed in terms of a0, and when you take a3 will be in terms of a1, so on. So therefore when n is 0, okay, so here n will start from 0 1 2 so on. So when n is 0, you will get the value of a2, so that is minus p into p plus 1 by 1 into 2 a0 varum. A3 will be minus p minus 1 into p plus 2 2 into 3 a1. Then when you find a4 will be minus p minus 2 p plus 3 by 3 into 4 into a2. So multiplying a2 you will get minus okay plus sign varum p minus 2 p plus 3 p plus 1 a0 by you will get 4 factorial, and again when you find a5 will be minus of p minus 3 p plus 4 by 4 into 5 varum a3 ആയിരിക്കും വരുന്നത്. Now substituting a3 you will get, so plus sign varum, so p minus 1 p minus 3 p plus 2 p plus 4 by 5 factorial into a1 will come, and similarly when you take a6 will be minus p minus 4 into p plus 5 by 5 into 6 a4. So we will get minus p into p minus 2 p minus 4, then p plus 1 p plus 3 p plus 5 a naught by 6 factorial. അതുപോലെ a7 എടുക്കുമ്പോൾ a7 will be minus p minus 5 p plus 6 by 6 into 7 a5. So that will be minus p minus 1 p minus 3 p minus 5. Then you have p plus 2 p plus 4 p plus 6 into a1 by 7 factorial. So you will get in this form. So now you have coefficients which contain a0 and coefficients which contain a1. So when you write y, you will get a0 into, so you are going to get in the form 1 minus p into p plus 1 by 2 factorial x square. Then the x raised to 4 in the term varum p minus 2 p plus 1 p plus 3 varum by 4 factorial into x raised to 4 adutha x raised to 6 minus p minus 2 p minus 4. Then you have p plus 1 p plus 3 p plus 5 by 6 factorial into x raised to 6 plus etc. That will be the coefficient of a0 common ആയിട്ട് വരുന്ന terms അതായിരിക്കും plus a1 into first term is x, then minus p minus 1 into p plus 2 x cube by 3 factorial, then plus you will have p minus 1 into p minus 3, then p plus 2 into p plus 4 x power 5 by 5 factorial, then minus of p minus 1 p minus 3 p minus 5 varum, then p plus 2 p plus 4 p plus 6 x raised to 7 by 7 factorial plus etc. So this is going to be our solution. So this is the power series solution. And the functions defined by the series. So this function, so let us call it as equation 1. So the functions defined by equation 1 is called, so these are called the Legender's function. So that is Legender's functions. And when p is non-negative integer, so when p is a non-negative integer, what happens is one of the series terminates. So you have a0 into one series, then a1 into another series. So when p is a non-negative integer, so one of the series will terminate and we'll obtain a polynomial which is called as the Legender's polynomial. So if p is even, the first series is going to terminate, and if p is odd, the second series will terminate. So that gives us what is called the Legender's polynomials. So when p is non-negative integer, one of the series terminates and is thus a polynomial. So the first series terminates if p is even, and the second series terminates if p is odd. So these are called, so these polynomials are called Legend is falling.